Let's start lesson 9.4 with a quick review of the Pythagorean theorem. So if you remember, we use Pythagorean theorem when we're trying to find the third side of a triangle. And if you notice, it has to be a right triangle. It can be both legs, it can be a leg and a hypotenuse, or the other leg and the hypotenuse. But either way, it is a right triangle, and Pythagorean theorem would be, so since this is missing a leg, I'm just going to call that leg A. So this would be a squared plus 6 squared equals 10 squared, which would be a squared is equal to 10 squared minus 6 squared, which is 100 minus 36, which is 64. And then we just take the square root of both sides, and we would get a equals 8. Now also, when you take the square root, you normally have to think of a plus and minus answer, but since this is distance, we only use the positive one. So there's a quick review of the Pythagorean theorem. Now we want to talk about what we've done so far in this unit. When you have triangles that you know 3 of the 6 pieces of information. So there's 3 angles, 3 sides, and we could do a quick statistics problem with this. If you have 3 angles and 3 sides, what combinations of 3 could you know? Well, there's actually 6 of them. So we could have 2 angles and a side. The 2 angles could be together, and the side on the side of them, or the angles could be on the side of the side. So angle, side, angle. Or if you have 2 sides and an angle, and the angle is not in the middle of the 2 sides that you know, that's when we use law of sines, and that was all about 9.3. So what about the other 3 possibilities? What about angle, 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 or side, 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 or side, angle, side? Well, if you have triangles that are angle, 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 those are similar triangles, and their sides could be anything. So their sides are not necessarily going to be the same. So that's a whole other case. And you talked about that a lot in secondary math too. So the last 2 cases that we're going to talk about is what if you just know the 3 sides of a triangle? This one is really common. Like I can think of a lot of examples in real life where you would need to use this. If all you know is the 3 sides of a triangle and you need to find maybe the angles or the area. We're going to talk about both angles and areas of these. The other case is 2 sides at an angle, but the angle is in between the 2 sides that you know. So our essential question for 9.4 is, what is the law of cosines? Law of cosines is going to be so helpful when we're looking at these kind of problems. For example, and to help us see where the law of cosines comes from, you could go to an activity. I'll show you that in just a second. But we're just going to jump right to the formula in the interest of time and, you know, this whole online learning stuff. So what if you just know the 3 sides of the angle or this triangle and you don't know the angle? So pretend you don't know these angles even though they're given here. You have a table in your notes, and I want you to complete that. So you will find C squared, A squared, B squared, angle C. And then the formula we're going to use is A squared plus B squared minus 2AB times the cosine of C. So take a second right now, turn off the video for a second and figure this out. Fill in the answers here. Okay, now that you've done that, here are the answers that you should have found there. So side C, side A, side B, AC squared, B squared, and angle C. So let's say that all you know are the 3 sides and an angle. Or maybe you just know just the 3 sides and you want to find that angle. Or maybe you know 2 sides and an angle. So, you know, and it's, remember, side, angle, side for these. So here's the formula. A squared plus B squared minus 2AB times the cosine of C. A squared is 9.9, B squared is 39.94. 2 times a times b times the cosine of c, you should have gotten 23.97 if you round it. You add all those, subtract the last one, you get 25.96, or approximately 26 degrees. So notice that that is the same thing as c squared. So now here we have our formula. C squared is equal to a squared plus b squared minus 2ab cosine of c. Listed in your resources of this module is a GeoGebra discovery activity if you want to see where the law of cosines come. Now if we were in a normal classroom setting, we would do this together, but if you want to, if you feel like you have the time or you're just curious about this, you can go to this page right here, Law of Cosines Discovery. You'll slide this over first and then go through and answer questions, and it's a really cool activity to help you see where we do get the law of cosines. In your notes, be sure you write this down. We're going to use the law of cosines when given side angle side or side side side. So make a note of yourself, that's when we use law of cosines. And here are the law of cosines. Be sure you write these three formulas down. Now notice one thing. Let's say we don't know what side A is, but we know B, C, and angle A. So then that's when we'd use this one. If we don't know what side B is, we would use this one because this we would know side A, side C, side A and C, and angle B. If we don't know side C, we use a squared plus b squared, ab cosine, if we know angle C. We can use any of these if we are looking for angles. Like if we're looking for angle A, we could use this one, and then we just fill this in. We know a squared, b squared, and c squared, and we fill in all the blanks there. So we're going to do some examples showing how we use the law of cosines. Starting with number 1. We're going to solve the triangle, and I like to start by just identifying SSS. Yes, these are the three sides that we know. So I'm going to start by finding angle C. So that way C squared is going to be what I start with. So I write C squared equals, A is 4, so A squared plus B squared, minus 2 times A times B times the cosine of C. So I just plugged it all into the formula. 5 squared is 25, 4 squared is 16, 6 squared is 36, 2 times 4 times 6 is 48, cosine of C. 16 plus 36 is 52, so I'm going to subtract 52 from both sides. I get negative 27 equals negative 48, cosine of C. I'm trying to get the cosine of C alone, so I divide by negative 48. Negative 27 divided by negative 48 is 0.5628. And that's what the cosine of C is. So I take the inverse of cosine of C of this 0.5628, and I get C is equal to 55.8 degrees. So that is now C. Now I need to find A or B. You could continue on with the cosine function, but I like the sine function if I can use it. It's just a little easier. So I'm going to use the sine function now to solve the rest of the triangle. So I'm going to say the sine of 55.8 over 5, and let's find A. So sine of A over 4, because the opposite side of A is 4. I grab a calculator and I go 4 times the sine of 55.8, find an answer, divide by 5, and I get a decimal, 0.66166, blah, blah, blah. So I have to find the angle of A. So I take the second sine of my answer, or the inverse, and I get 41.4. Okay, now at this point, I know two of the angles. I know that all the angles add up to 180, so I'm going to solve it by using that fact. So 180 minus 41 0.4 minus 55.8. So the final angle B is 82.8. And there we have just solved all three angles. We found them, so we have solved the triangle. Number 2, the directions say to just find angle A. So angle A is what we're looking for, so I'm going to use the formula that has A squared. So it's going to be 23 squared equals 16 squared plus 27 squared. And you should always show your work on this because you just never know where you're going to forget and put the wrong number down, or make a tiny little mistake. So this time I'm looking for cosine of A. Now I remember what I did last time, so I have 16 squared and 27 squared. That's equal to 985, so I'm just going to subtract 985 from both sides. Someday I'll be good with writing with a mouse, but not today. Okay, so I have 985, and I'm going to subtract it from 23 squared is negative 456. Is equal to, I'm going to take 2 times 16 times 27 is 864 cosine of A. So in your notes you should have at least this much work written down so that you can remember how to do this problem. If you're just looking at it and thinking, oh yeah, I know how to do that, you're not going to remember, and during the test or a very important time in your life you're going to forget that. So 456 divided by 864 is 0.5277, but I want to find the inverse cosine of that, so I do inverse cosine of that answer, and I get that angle A is equal to 58.1 degrees. And we will usually round to the nearest tenth. All right, this next one says to solve the triangle. I notice that I know two sides. I don't know the third side. I know one of the angles, so I got to find that. So I'm going to be looking for side B, and I'm also going to be looking for angle A and angle C. And it doesn't really matter where you start. You just kind of look at it and just pick a point that you feel comfortable with. So I'm going to, let's see, can I do sines? Law of sines. Well, I know this angle, but I don't know this side. I know this side, but I don't know its angle. I know this side, but I don't know its angle. So I'm going to have to use the law of cosines. And I'm going to start out to do it for side B. So B squared is equal to A squared, which is 11, and 14 squared minus 2 times 11 times 14 cosine of angle B, which we know, so it's 34 degrees. So this time I'm going to be solving for B. Now the cool thing with graphing calculators, not just good for graphing, but on this one I can just go ahead and put that whole equation into my calculator. Just be sure that you put it in correctly. So you have 11 squared plus 14 squared minus 2 times 11 times 14 times the cosine of 34 degrees. When you hit enter, you get B squared is equal to 61.7 if we round it to the nearest tenth. So 61.7 is what B squared was, so I have to take the square root of that number, which I can put in my calculator as answer, and I get 7.9 rounded to the nearest tenth. Okay, now to find A, I now know that all three sides, and I know one angle. So I'm going to use the law of sines to find angle A.